Hi, I am Sougata Ghosh and I would explain in this video the basic concepts of median, which is a measure of central tendency. To start with, let us understand what is a central tendency. Central tendency is a single number that gives a good sense of the bigger data set it is representing. For example, average is a central tendency. Let us understand why. Suppose I ask you to evaluate the performance of a batsman who has played in 200 matches. Now you could go and look into each and every single performance of his and come to a conclusion, but that you would agree would be a tiring and tedious exercise. Alternatively, you could just look at his average. Although the average may differ significantly from the actual performance he has delivered in some of the matches, it still gives you a good idea about how he has performed over a period of time. In other words, the average, which is a single number, can be used as a representative of his overall past performance, thus making the average a measure of central tendency. Now there are three widely used measures of central tendency: the mean, the median and the mode. In this video, we talk about the median. In this slide, I would like to highlight the importance of median as a measure of central tendency, especially as an alternative to mean. Now the reason why we need an alternative is because there are cases when the mean does not represent the data correctly. Let us look at such a case. Here I have given you the performance of two players over 8 matches. The performance of these players are exactly identical for the first 7 matches. However, player 2 has performed exceptionally well in the 8th match, scoring 300 runs, while player 1 continued his poor form even in the 8th match. The last column calculates the average runs that they have scored per match. What we now intend to do is to try and understand if these averages correctly represent the respective performances. For player 1, the average of 3.5 runs per match seems to be quite in line with the actual performance that he has delivered and therefore can be taken to be a good representative of his overall performance. However, for player 2, the average of 40 runs per match is a bit misleading. The reason is he has performed very poorly in 7 of the 8 matches. But if you look at the average in a standalone manner, it paints a far better picture. And because of this discrepancy, the average in this case is not probably a very good representative of his performance. You should understand that the discrepancy results from you should understand that the discrepancy in the actual performance delivered by player 2 and the performance as highlighted by his average results from the very high score of 300 that he has scored in the 8th match. In fact, the number 300 is so much higher than the rest of the dataset that it ends up dominating and distorting the calculation of the average. Such numbers are called outliers, and it can be taken as a general rule that mean is not a very good measure of central tendency in the presence of outliers. In that case, median is a better choice. So let me now define median for you. Median is the value at the middle position of the dataset after the dataset has been arranged in an increasing or decreasing order. So to compute the median, you need to do 3 things. First, you need to arrange the dataset in an increasing or decreasing order. Next, you need to find the middle position of the dataset. And finally, you need to record the value at the middle position, which would give you the median. Let us try this with an example. Here I have given you the salary of 7 people and we would like to compute the median salary of this dataset. So the first step involves the arrangement of this dataset in the increasing order, which is done. The next step involves the finding of the midpoint of this dataset. Now since we have 7 data points, it's obvious that the middle position is the 4th position. And the final step is to record the value at the 4th position, which is 13, which is also the median salary for these 7 persons. So this was fairly basic and easy. And now let us see what happens if we add one more data point to this data set. So now I've given you the salary of 8 people, and we again want to compute the median salary of these 8 people. The first step remains the same, that is, we have arranged the data again in the increasing order. However, the difference comes in the second step where we find the location of the midpoint. Because we have an even number of data points, we do not have one but 2 middle points in this case. In fact, the 4th and the 5th position together form the midpoint. The reason why the 4th and the 5th position needs to be treated as one unit is because they collectively represent a location that has an equal distribution of data points around itself. So if you consider the 4th and the 5th position as one unit, then you'd see that there are 3 data points to their right and 3 data points to their left, justifying their consideration as the midpoint of the data set. Now, since you have 2 middle positions, you would have 2 values corresponding to those positions, and therefore the median in this case would be the average of the values in the 4th and 5th position, which comes out to be 13.5. So to summarize, the calculation of median would involve 2 cases. In one case, the number of data points could be odd. In that case, the median would be given by the value at the n+1 by 12th position, which would be the midpoint of the data set. In other case, the number of data points could be even, and you will have 2 midpoints in that case, given by n by 2 and n by 2 plus 1th position. The median would be the average of the values at those positions. Now let us compute median for a data set in which the data points are not all unique, as shown over here. The reason I choose to do this exercise is because I want to show to you how to use the frequency table to compute the median by following the same 3 steps as before. The reason behind using a frequency table is that sometimes for bigger data sets, it might be difficult to manually locate the midpoint of the data set. In those cases, doing it manually may lead to an error. Now, as required by our first step, I've already arranged the data in an increasing order. Now please realize that there are 15 data points, and therefore the median would be in the 8th position. Now after we have arranged in the increasing order, let us now understand how to form the frequency table. The first column of the frequency table records the unique values that are present in the data set. In our case, we have 3 unique values. The next column has the frequency, which gives the number of times each of these unique values are present in the data set. And the third column calculates the cumulative frequency, which tells you the starting and the ending positions of each of these unique values. So for example, the cumulative frequency of 2 for the unique value of 0.5 means that 0.5 represents the first 2 data points in this data set. Now since the first 2 data points are occupied by 0.5, the next unique value of 2 can only appear from the 3rd position and will span 4 data points up till the 6th position. Similarly, the 3rd unique value of 3 will start from the 7th position and will continue up to the 15th position, spanning 9 data points. Now if you understand the cumulative frequency column, then you would immediately realize that the 8th position corresponds to the value 3, which therefore becomes our median value. Now please realize that this frequency table is to be used for big data sets so that the chances of you making an error reduces. The principle of computing the median has not changed. Now this has brought us to the end of the video. Now the calculation of median for group data is not being covered in this video for the want of time, and I'll make a separate video for it. So thank you for your time and goodbye.